right, hey, welcome. I haven't had one of these for a little while, so we're going to get rolling on it. It's called What is a Function? So that's the question that we hope to answer throughout this video. What is a function? I'm going to go full screen, so perhaps we're a little less distracted. Don't know what that's about. But meanwhile, what is a function? Give you a first example. A soda machine actually can be thought of as a function. It represents a function as we work through the video. Hopefully you'll be able to pick up on what I'm talking about. Generally speaking, when we talk about a function, the most basic definition of a function is that we've got some sort of a box. Okay, we put something into the box, and something different perhaps comes out. Okay, so we have an input, that's what goes in, and we have an output, that's what goes out. And whatever happens inside the box, well, it depends on what the actual function is. Okay. For instance, if I take all these ingredients here, and I do this to them, and then I do that to them, I get a certain output. Okay, and the output that I get is the same output, I would think, every single time that I follow these particular steps and directions, and that's these chocolate chip cookies. You might have noticed by the chocolate morsels that that's where we were heading, and then you can have it with or without nuts, your call. So when we're talking about a function, we want to have some sort of predictability, because I don't want to put these ingredients in my oven one time and get chocolate chip cookies, and the next time they come out to be oatmeal cookies. Okay, that doesn't make any sense. It wouldn't be predictable. I want to, if I follow a certain recipe, if I perform certain operations, I should get the same result every single time. Okay, so let's go for another example here. If I tell you the name of a team, can you tell me what city it's in? You can. Okay, the Bengals, they go with Cincinnati. The Sabres, their hockey team, they go with Buffalo. The Heat, basketball, goes to Miami. The Braves go with Atlanta. So this one is a function. It's fairly predictable. If I tell you the name of a team, you can tell me the name of the city. Okay, so this one would be a function. Okay, the name of the city depends on the name of the team. If I went the other way, and I started with the name of a city, could you tell me the name of a team? Probably tell me the name of a team, but I probably would not get the same answer from everybody that I asked, because if I went with Cincinnati, I might get the Bengals, I might get the Reds. If I said Buffalo, I might get the Sabres, I might get the Bills. If I said Miami, I might get the Heat, I might get the Dolphins. Atlanta, that's in two places. Okay, so this is not really predictable. Okay, my input city is not going to give me a predictable output. So I'm not able to necessarily give the name of a city and you tell me the name of a team. There's certain cities where it would absolutely work, where they only have one team. Like, I guess I'm thinking Charlotte. Charlotte has just got the Bobcats. I think that's what they're called at this point, so that wouldn't necessarily be that way. But the issue is, in this one that is a function, every input goes exactly with one output. In this situation, my inputs go in two places, so it's not predictable. I can't predict what's going on. Okay, so what I want to say for function is a couple things we want to note, and we'll probably get a little more clarity on this. Every input is paired with only one output. Okay. The thing I also use for that is I want it to be predictable. I want to know what's happening as I move forward. Okay, I want to be able to know that when I put those ingredients in the oven, I'm going to get chocolate chip cookies. Okay, that's what I want to have for the predictability. All right. So when we get to numbers, so far we've talked about everything but numbers and math. Here's what I want. I want to have that predictable range. I want to be able to put, and this is just some random sets of ordered numbers, but we can figure out some sort of a pattern. Okay, so this one is a function. Function. This one is not a function. If you look, you might be able to hopefully see a real difference. It's sort of like the the team city thing. Okay, in this case, 1 is paired with 2, 3 is paired with 5, 6 is paired with 1, 8 is paired with 23. Great. Okay, it doesn't necessarily have to be rules, just some random numbers that I generated up here. Okay, this one that's not a function, 1 is paired with 2, 3 is paired with 5, 6 is paired with 1, 1 is paired with 23. Wait! 1 was already paired with 2. How can 1 be paired with 23? Okay, so I mean, if I go here, I go 1, 3, 6, 8. I've got 1 going with 23. I've got 3 going with 5. I've got 6 going with 1, and I've got 8 going with 23. If I do this other one, I've got 1, 3, and 6, and sometimes 1's with 2, sometimes 1's with 23. Okay, that's an issue. Okay, the 3 is with the 5 and the 6 is with the 1. That's fine. Okay, but this is not predictable. I don't know when I put back to the little machine, input output. I don't know when I put the ingredients in the oven whether I'm going to get number 2 or number 23. I'm going to get peanut butter cookies or oatmeal raisin cookies. It's just hard to tell. I need it to be predictable. I don't want my numbers two-timing. I don't want my x variable, my x things, doubling up. Boyfriends, girlfriends, they shouldn't two-time you. Numbers shouldn't two-time you either. Okay, that's what we're talking about. Oops, let me need to just do a little quick magical trick here. I think that's the screen that I want. Yep, hold on. I want to clone the page. Boom, there it is. And then I want to move it right there for right now. All right, and then let's go there. Okay, back to full screens, not to be distracting. So what we typically look at when we're talking about ordered pairs is that I have no repeated x values. Okay, I don't want my x values repeating as I work through this. Okay? The other thing that we look at is what's called the vertical line test. If I have a function, it should pass the vertical line test. And let me show you what I mean by that. Here's a vertical line. Vertical goes straight up and down. Okay? I can grab hold of this vertical line. This one, there was a function. That was my first set of ordered pairs. As I move my vertical line throughout these ordered pairs, you might notice that my vertical line only touches one point at a time. Okay? This one is a function. Okay? On this one, right there, I'm hitting 2 right there at this point. I'm hitting 2 of these green dots at the same time. Okay, over the rest of the way I'm good, but as soon as I cross one, my vertical line touches more than one place at one time, I fail the vertical line test. Okay, so this one is a function. This one is not a function. The vertical line test basically just says the vertical line can only cross, I'm going to say, one point at today at a time. We can only cross one point at a time if we're going to pass the vertical line test. Okay. So let's look at the vertical line test as we move here. So we move through these pointer. Okay. This one passes the vertical line test. Okay, I'm only hitting 1 point on that diagonal line at a time. Okay. If I go over here to this shapy thing, the parabola. Okay. Look, passes the vertical line test. If I go down here to red line. Okay, good, 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 good. Ooh, bad right there. As soon as I hit one place where it's bad, we know it's bad. So if I grab hold of my pen, this one's a yes. This one's a yes. This one's a no, not a function. Okay, so we need to back up a little bit. Let's go back here. Okay, so if it's a function, we pass the vertical line test. And we know that the vertical line test is the fact that we can only cross the function one time. Okay, that's this. As soon as I hit these 2 points with my vertical line, so we have an issue. Okay, here, same thing. All right, so the other thing, just so you get a little mathy on you, a little more mathy on you, function notation. So you'll see this, like f of x. So let me write how we say that. The f of x. That's the math speak for this. It doesn't mean f times x, it means the f of x. And we'll talk further about how we're going to deal with that, but just wanted to throw function notation out at you one time. This one we'd call the g of x. Okay, and this one we'd call the h of x. So, in terms of input output, that means that this f thing depends on x. G depends on x. H depends on x. So if we put an input of x, we get h out of the thing. Okay, that's just the notation that we'll use Now you're probably used to things like y equals 3x plus 4, y equals x squared minus 4, y equals the absolute value of x. Let's make that plus 3. Okay, that's what you're used to. In this case, we're just going to use the f of x, the g of x, the h of x. The letters are sort of arbitrary, but that's just the notation that we use as we become a little more sophisticated, and we'll get into that a little more. Okay, function notation. Last thing, there it is. Here's a little something I want you to think about. Back to the first slide I showed you the soda machine, and I said it is like a function. Here's the Snapple machine. It's down in the lobby by the guidance office. How's the Snapple machine like a function? How's it not like a function? So look back at the definition of the function, fill in a couple of pieces of information about how it's like a function, how it's not like a function. Okay? Should about do it, I think. I don't know what I just did there, but let's get this up. And 11 minutes in. So thanks for watching. Get some answers to these last little questions. Hope you learned something. And if you have questions, please. Tomorrow would be a great day to ask them. Thanks. See you.